Purification of organic compounds, partition chromatography. This technique was based on the differential partitioning of the sample of the component of the sample mixture between the two phases, that is stationary phase and the mobile phase. Okay, so this is the differential partitioning. Differential partitioning of the component in the sample mixture, of the component in the sample mixture between the two phases, that is stationary phase and the mobile phase. Okay. So due to the partitioning of the component, so this got the name, this chromatography got the name partition. Okay. Here one of the example for partition chromatography is paper chromatography. Okay, paper chromatography. In paper chromatography, the stationary phase will be a paper. Okay, special quality paper is used in which water is trapped. Okay, so it contains water which is trapped in the paper. So this is the stationary phase. Okay, now next we have to mark the baseline. Okay, mark the baseline 2 centimeter away from one end of the one base of the paper. Okay, and a sample spot is made on this baseline, sample spot, of which we have to separate. Okay, so sample spot of the solution or the mixture we have to made, which we have to separate. Okay, next step is we have to suspend the paper in a solvent contained in the jar. Suspend the paper in a suitable solvent. Okay, in a suitable solvent. Okay, and the baseline must be above the layer of the solvent. Okay, next the solvent or the mobile phase, this is also the mobile phase. Okay, which is the eluent. Okay, now the eluent started moving up. Okay, eluent moves up. Along with that, the spot also moves up. Okay, and this eluent flows above the spot. Okay, above the spot. At that time, there is a partitioning of the component is taking place. Okay, partitioning of the component between the two phases. Here, one phase is a solvent and the other phase is the water trapped in the paper. So, a partitioning of the component is taking place and different spots are produced in the paper. So, a chromatogram is developed. Okay, chromatogram is developed. Here we can notice that this is the baseline on which the first sample spot is made, and this moves up and the solvent front flows over the above this spot. Okay, so these are the spots. Different spots can be identified. Okay, these spots can be identified by using RF value. Okay, RF value or retardation factor. Retardation factor. Okay, so different spots will be at different distances from the baseline. So using the different distances, we can calculate retardation factor, which will be equal to distance moved by the substance or the spot from the baseline by the distance moved by the solvent. Okay, RF value equals distance moved by the component. Okay, component by distance moved by the solvent. Okay. So from this we can calculate different values and we can compare this with the standard value and we can identify the different compounds present in the mixture. Okay, this is the method we are using. So we can identify if the spots are colored, maybe green, yellow, like that, we can identify those spots with it is visible. But in some cases it is colorless. In such cases we are using the same method like which we have to keep under UV light. Keep under UV light. So the spot become fluorescent, or we can spray different appropriate reagents to identify the components present in the mixture. Okay, spray appropriate reagent, or we can use the iodine crystals, brown spots can be identified. Now next is the different applications of partition chromatography. Applications of partition chromatography. First one, it is a qualitative method of identify components of a given mixture. Okay, identify components, okay, in a given mixture. First point. Second point is used to identify drugs and impurities. Okay, identification of drugs and impurities. Next, third point, it is used in the forensic studies. It is also used in the analytical chemistry. For the study of organic compounds in the mixture. For the students, this is used in analytical chemistry to introduce them for the students. Okay. Next, identification of biomolecules, organic and inorganic compounds, etc. can be identified. Okay, identify biomolecules, organic and inorganic compounds. Okay. Next, it is low cost and it is a rapid method of separation. It is low cost and a rapid method of identification. Easily identified, rapid method of identification. Okay, these are the different applications of partition chromatography.